Looks like we're live. Hello everyone and welcome to yet another recreational programming session. How about that? But you didn't expect that shit to happen. But you didn't expect that. So let's make a little bit of an announcement and officially start the stream. Red Circle live on Twitch. And what are we doing today on Twitch.tv website? Today we are generating I said, videos with neural networks in C, of course. I'm gonna give the link to twitch.tv/studying, the place where we're doing all of that, and I'm gonna ping everyone who's interested in being pinged, and there we go, the stream has officially started. There we go. So today we continue working on NN.H, which is the deep learning framework in C that we've been developing for quite some time already. I don't know for how long, but it's been quite a few streams, right? So you can find the link to this thing here. I'm going to copy paste it in the chat. And for people who are watching on YouTube, it's going to be in the description, right? So what we're doing essentially, we are exploring a completely new for me paradigm called machine learning. And we do that by implementing a deep learning framework, right? So essentially in the previous streams we were experimenting with interpolating two images, right? So let's actually take a look at the experiments, right? So I'm going to start TeamUX, I'm going to go into the folder where we're developing all of that. All right, so I'm going to rebuild everything just in case, because I don't quite remember if I did all of that. So let me bring up the RayLib environment and I'm going to do the build. While it is building, I'm gonna put something behind my camera so I don't see the things you guys don't see, so we are on the same page, right? So that's how I usually do that. Yep. So, and I'm gonna start the image to NN application, which basically trains a neural network to interpolate between two images. The thing we have to do is that we have to provide the two images, right? So we have a couple of images from NIST dataset, right? So we're gonna provide the 8 and we're gonna provide the 6, right? So these are the digits that we're providing to this entire thing, and there we go. Here is this sort of like a gym, right? The gym for the neural network to train itself. This architecture is a little bit too deep for my liking, right? So it has like 5 layers. This kind of stuff is kind of difficult to train with the activation function and the method that I use. So I'd like to actually reduce the complexity of this entire neural network. Just a second. So let's actually go in here. Right, so this is how many layers we have. We have 3 input layers and we have 5 hidden layers and 1 output layer. I would like to bring this amount to 2, 11 and 1 9, right? So I remember that this kind of architecture actually worked well, and let me actually rebuild this entire thing real quick. Right. So it's the architecture is sort of baked into the executable, right? So that's why I have to rebuild this entire thing. And there you go. So it's a little bit simpler, so it's a little bit easier to actually train. So, and let's actually start the training process. So basically on the left, you can see this. This is how it acts as the first image, and here it acts as the second one. All right, so here I have a slider, and the slider basically controls the learning rate. So here I can manually adjust the learning rate when I see that the neural network goes too crazy. As you can see here, it just goes a little bit too crazy. I just like bring the learning rate a little bit down and calm it down a little bit. So as far as I know, you're supposed to actually do that programmatically, automatically, but for the learning experience, I decided to actually put it in here in control of the user, and it's actually kind of convenient, right? So to be able in real time to control the learning rate. So people use different functions to control the the learning rate, but what you can do, you can use another neural network to control the rate of learning of the initial neural network, and you can even use your own neural network to control the learning rate. Right. This is actually funny, right? So you're using one neural network to control the learning rate of another neural network. Anyway, so, and basically this is how the neural network acts as the first image, and this is how it acts as the second image. And how it's supposed to act is controlled by the third neuron, right? If you put 0 in here, it will act like an 8, and if you put 1 in here, it will act like a 6. So how do we achieve the interpolation? Essentially, if after training this entire neural network, right? So we already trained it to its limits, so it doesn't really go any better than this. So when we keep training it, it just keeps shaking. It just tries to adjust some parameters, but it couldn't find anything better. So it basically solves the problem, right? If you put a value that is neither 0 nor 1 or something like half, it will start interpolating between these two images, right? So this slider is basically the value that goes into this neuron. So these two are the coordinates of the image. This one is the brightness that will be taken either from first image or second one, and this is the interpolation. And we're able to actually interpolate between these two things. And depending on how you train it, it's going to interpolate differently, right? So we can try to start over, right, and train it again. And the interpolation itself is going to be slightly different, right? It's just depending on what kind of route it went. Right. So sometimes it cannot really close the 6, right? It takes a lot of time to close the 6. We can restart it one more time because it's kind of a difficult shape, right? It's sort of like a loop, and for a neural network sometimes it's kind of difficult to just sort of like close this entire loop. Right, so we can slow down its learning process. And now if we try to interpolate, it's slightly different now. But here's an interesting thing. We are using normalized coordinates, right? So that means we can upscale those images to any resolution we want, right? So I have a special key in here. If I press S, it will generate a screenshot at a higher resolution of the current image, right? So if we take a look at upscaled, this is how it looks like. This is basically an 8 reproduced by the neural network, upscaled to 512 by 512, right? So that's basically what it is. But you can actually put something like in between, right? So something like here, and let's actually rewrite this entire image, and this is how it's going to look like. So it's using mathematical functions to interpolate those things. And look how sort of like dreamy it is. You can notice how sort of smooth and dreamy it is only when you upscale this entire thing. Right, we cannot really upscale it here in real time because it takes quite some time to generate one single frame, so we cannot see that in real time. And I was thinking, what if we add a new functionality to this gym? So essentially, when I press a special key, it will actually render a video out of the interpolation. So essentially it will render a continuous video where it basically increases the value of the interpolator from 0 to 1, and just within like 5 seconds it animates that transition at high resolution, and we can actually see this sort of like a high resolution picture in motion. Right, so what I want to see a smooth animation like this, but at high resolution, actually, and like arbitrary high resolution, because again, all of the coordinates are normalized. You can scale it as much as you want, right? So you can scale it indefinitely, right? So, and that's what I want you to do today. Right, so that's basically the topic of today's stream. We're gonna literally generate 60 FPS high resolution video of one digit interpolating to another one. Doesn't sound cool? Sounds Gucci? Sounds Tamaguchi? Let's go. Hello everyone. So I suppose we've got some subs. We've got only one sub, right? Nobody gives a shit about me today. But anyway, thank you so much everyone who subscribed yesterday. And for Dakin, thank you so much for Twitch Prime subscription. 7 minutes ago I was doing intro. But yeah. Hello, welcome. So, all right. So how are we going to be doing all that? That's a very interesting question. So the usual thing we can do is essentially just generate each frame and save it into the PNG, right? Save it into the PNG, and then call FFmpeg and assemble those PNGs to like a single final video. Right, but some time ago, I saw somebody doing a actually pretty cool thing, and I think it was MM2PL, but I don't quite remember. I think it was MM2PL. So essentially, FFmpeg has a very cool feature where it can read the video that you're trying to convert from the standard input. And one of the formats it supports is raw frames, right? So essentially, you can, using some special flags, you can get FFmpeg into the mode where it will read from the standard input literally the binary bytes of frames in RGB32, and it will automatically in real time assemble them into a video. So essentially what you have to do, you have to write a program that starts up FFmpeg as a child process, opens up a pipe between your program and FFmpeg and feeds the raw data into FFmpeg, and FFmpeg is going to actually spit out the output video, right? So we can even draw this architecture to demonstrate that a little bit better. Oh, it was, yes, you did that with the FFmpeg in the Discord General 3. Okay, so yeah, I remember. I think it was when we were doing the Olivet's videos, right? So, Olivet's streams, right? So somebody actually did an animation with Olivet's and submitted that in general. Right, okay. So essentially we're going to have image, right? So image NN, actually it's image2 NN, right? So this is basically our application. So this entire thing will start FFmpeg, right? FFmpeg, like so. Then it will establish a pipe between itself and its child process FFmpeg, right? So this is the pipe, and it will start sending frames, like raw frames, into FFmpeg, and then FFmpeg in real time is going to just render the video onto the file system. So it's going to be output MP4, right? Output MP4. So that's basically the architecture, right? So we can try to Google up how it's supposed to do that. So let me see. So there were some flags. FFmpeg read raw frames from stdin. Let's actually use Google this time. FFmpeg raw video audio stdin. We don't really need audio today, alright? So I suppose we're not gonna do that. This one, pipe FLV to Annex B, write raw video. I think this one could be useful, but not really. So let's take a look at the Stack Overflow. I suppose it loaded up. Yeah, this is basically what we need. So you put an input as dash. You say that the format that you're feeding into the FFmpeg is raw video. You can set the codec to be raw video and PixFMT. So here they use BGR24, but I would like to use RGB32, right? So because it's just like very easy to work with, if you know what I mean. So here this is S, and I don't remember what is S. I think, oh, this is a resolution, right? So essentially the size 0, size 1, and so on and so forth. So this is going to be the resolution, and then we have to provide the output in here. So yeah. So probably have to provide the codec and stuff like that, but that's basically roughly the flags that we need to have in here, right? So I'm gonna actually, you know, put that in the description, right? So because it's sort of a reference how to read raw frames from stdin in FFmpeg. So this is basically sort of the main thing that we're gonna have in here. Right, so to practice how we're gonna do all of that, because doing all of that in C is kind of like a little bit tricky, right? So I suppose what we'll need to do, we need to have like you know, separate like a setup where we can try to practice how we can run you know, FFmpeg as a child process, right? So because we have to do that in C, right? So an only thing we have at our disposal is libc, and even libc is not that useful in this specific case. We have to use the Linux syscalls, right? Because you're supposed to create a child process, you have to establish the pipe. All of that is very much operating system related things, right? And just libc is not going to help you much, right? You have to work with the Linux syscalls. Of course, the glibc, it has wrappers around syscalls, but I mean, it's still syscalls. All right, so we're going really like low level, right? We're going really low level, and we're almost like touching the syscalls of operating system. That's how intimately we work with operating system. We're just slightly touching our code and the operating system syscalls. They're touching. That's how intimate it is. Anyways, so what we're gonna do. So let me create some sort of like probe. And what I want to do, I want to just like generate a video, right? Generate a video maybe of the ball bouncing off of the walls of the video or something like that. So let's give it a try. So it's going to be ffmpeg bouncing ball in C, right? So that sounds like a pretty good name for this entire thing. And let's create a main.c file. So stdio, and let's actually do the hello world, of course. Let's say printf hello seaman. Right. So let's actually do build sh, right? And we're gonna do a bin sh. We're gonna enable the tracing, so we're gonna see all of the commands that are executing in here. And we're gonna do clang main.c. And I probably also want to enable all of the warnings and all of the extra warnings just in case. Right? I think it does in fact make sense. And let's make this entire thing executable. Right? Let's make this entire thing executable and let's run it. And let me actually run it. As you can see, hello seaman. Right. So the first thing we probably need to do, we need to run an external process. Right, running an external process, a child process in a POSIX operating system is kind of a tricky thing. It's a two phases trick, right? It's a two phases trick. If on Windows you can just do something like create process. Oh, I don't really remember what's the API call for a create process, but like, yeah. So something like that. In POSIX operating systems, you have to first fork the current process, right? And then execute and then replace its executable with a different executable, right? So essentially, you can think of your process like this, right? So essentially, let's actually draw our process. So this is our process. There we go. So this is your process and it executes instructions until it goes into the, like basically runs into the fork syscall. At that point, operating system literally copies your entire process. Like it literally copies your entire process and continues executing this entire thing, right? So essentially, literally, all of the instructions that you had in here and after the fork and in here and after the fork are going to be copied. It's literally a copy. It's literally a copy of your process. And the next thing you have to do, you have to do in the child process, you have to replace this entire image of the process with a different image. And that is done with exec syscalls, right? There are several of them, but what they do, they essentially take the path to the executable and they replace the current thing with the new executable, and thus you have a completely new process with a completely different instructions, a completely different memory and stuff like that. So this is how basically it works. Right, but how do you know in which process you're running, right? Because you literally just did a fork, and if everything is the same, how do you know whether you are a parent or a child? So that's a very interesting thing. So you need to do exec, but like, how do I know? Like I did a fork, right? So I did a fork, and now I just have two copies of the same thing running, like in which copy I have to do things. Well, fork actually returns you the PID of the child. And in the child, if you are in the child, this PID is equal to 0, right? So the parent has the actual value of the child, right? So, and that thus it knows the PID of its own child, but the child cannot be a child of itself. So the only thing it gets is 0. So that means here, if this entire thing is 0, you're supposed to do the exec. So that's how you effectively do all of that. Right, so that's how we effectively do all of that. So here you do a fork. When you are in the child, you just do exec. So, but that has a very interesting consequence. You can put some additional code that is going to be executed in the child before starting the program. That's actually very interesting, like a consequence of this entire like two-stage system. So this is the code that is not the program that you're trying to run as a child process, but it's your own code before the actual child is gonna execute. And that is useful for sort of setting up the environment for the child before like the actual child program is going to execute, if you know what I mean. Right, it's kind of interesting actually. So yeah. Multiverse programming. Yeah, you have to think about processes like threads, I suppose, but they don't really share the memory, right? So as far as I know, in POSIX operating systems, like the difference between thread and the process is that threads do share memory and processes do not share the memory, right? So because that's the main difference. But then you can actually have a shared memory. So there is like a shared memory mechanism that allow you to share the memory between the processes. So it gets very muddy and confusing at some point, right? So like, what's the difference? What's the actual difference between thread and the process? I don't really know. So maybe like I'm also not a very low-level developer, right? Not a kernel developer. Maybe some like hardcore Linux hackers can tell me what's the actual difference, but yeah, I don't know. Also, each process has its own collection of threads. Yeah, I suppose. Yeah. Yeah, threads share the memory. The OS also cannot tell the difference between threads, as I understand. Interesting. Yeah, I didn't know that. Right. So we've got some subs. Thank you so much, MDDGWZRD, for tier 1 subscription with the message "Hello, Simon." Yes. All right. Hello. Let's continue. So essentially, there is also a possibility that fork is not going to work. So usually one thing I like to do is to actually check that the child is not less than 0. So we can take a look at the documentation of the fork. Right, so, and we take a look at the return. On success, the bit of the child process is returned in the parent and 0 is returned in the child, just like I explained. On failure, -1 is returned in the parent, no child process is created and error no is set appropriately. Okay, so essentially if the child got negative, that means there is no child process. The child process was not created in the first place because we failed to do so. So in that case, we probably want to actually report an error, say something like error. Classical POSIX could not fork a child. And here we can put some sort of a reason in here, yeah. So we probably want to do something like string and error no, if I remember correctly. Right, so str error, error no, and then return 1. Right, so this is basically what we try to do. Could not fork a child. So in here, we can do something like this, right? So we can do printf, we can say hello from child, right, hello from child, and here we can say, so here we can actually return 0, hello from parent. The child's PID is, and we can provide the number in here, so we can do child. There we go. So let's actually try to compile this entire thing and see how it is going to work. So we don't have a PID and fork in here, and this is because we need to include the POSIX specific headers, right? So POSIX specific headers, here they are. So systypes, unistd, you know, the usual stuff. It's like an equivalent of including windows.h on Windows, right? But on Unix, you're supposed to do unistd and some other things, right? So it's basically equivalent. Right, we're doing an equivalent of WinAPI programming, but on Linux. That's how low level we are. Just think about that. Holy fucking shit. Who does shit like that in 2023? Right. So yeah, on Unix you're supposed to have Unix H, of course, yes. But Linux is not Unix as far as I know. Okay, so let's actually rebuild this entire thing, and it seems to be working. Let's actually try to run it, and as you can see, it said hello from child and hello from parent, and the child PID is 22815. Right, and as you can see, if it was not creating a separate process, this code would never actually print both of the messages. And this is because one message was printed from the child, and another one was printed from the parent. So that's as simple as it is. Right, so the next thing we need to do, we need to actually basically substitute the current image of the child with the image of the FFmpeg. So it's usually done with exec functions, right? So there's several of them. So it's a whole family of the functions. They essentially do the same thing, but they kind of like act differently. So as far as I know, the ones that have a prefix p, they search for the program in a path environment variable. The ones that do not have p, they actually expect you to have like a full path. So in that case, we're supposed to use p, right? So on top of that, there is a v version, and v version accept the arguments as an array. The ones that don't have the v version, they accept the arguments as variadics. Right, and variadic arguments is basically, in C you can have functions that accept arbitrary amount of things, like printf. In printf you can put as many arguments here as you want, and that's what's called variadic functions, right? So because they have variadic amount of arguments. Right, so usually what I like to have, what I like to use, I like to use execlp, right, because I want this thing to search in the path environment variable, and I also like that it uses variadic arguments, so I don't have to create arrays or anything like that. But there is a little bit of a problem in here, right? So you have to be aware of how exactly it works. So you have to provide the name of the program, right? And you have to provide the name of the program one more time, because that's what gets passed into the arguments of the program anyway, right? So because if you programmed in C a little bit, you know that in argv, here in argv, the very first argument is the name of the program that was run. And that's exactly what we're doing here. So we're saying, okay, I want to execute FFmpeg, and I want it to find in path environment variable, and here are the arguments of that thing. And because the first argument is the name of the program, that's what you have to put in here, right? So essentially you put here the arguments that are going to be passed into the args of that program in here, and that includes the program thing. Why do the BTC transfers take so long? By the way, I'm really sorry that I can only accept BTC right now, and I'm really sorry that I cannot acknowledge them on the stream because I don't have a appropriate setup to do all of that. And I know that this kind of thing is very inconvenient. I plan to add more options to donate in the future. Unfortunately, I just can't find some time to just like sit down and learn all of the cryptocurrency madness, right? Because I also need to work on the content and prepare for the streams and also edit the votes. There's like a lot of things I have to do, and it's just like I also need to do the crypto thing. But I really appreciate whoever found time to still donate through BTC. I really appreciate that. So at some point I will get to that, and there will be more options. If it's very inconvenient for you right now, just don't donate anything. Right, if it's even mildly inconvenient, don't donate anything, just wait until I release more options, okay? So I don't really want to cause too much inconvenience, and I really apologize if I do. Right, so, but thank you so much. Thank you. Anyways, and another thing, what we have to do in here, by the way, we also have to end. So here comes the arguments, right? So here comes the arguments. So as far as I know, we have to put I and then dash in here. So here we can do something like this. 1, 2, 3, 4. Since we're gonna have a lot of arguments in here, it would be better to actually organize them like this, right? In like a big list, because we're gonna put a lot of things in here. Right, so we're gonna have in here. And if I remember correctly, yeah, so we have these things. So the format is going to be F, right, so this is going to be format, raw video, and so on and so forth, right? And at the end, right, so this is obviously not finished, right? This is obviously not finished. We have to put null in here, right? And null indicates the end of the arguments, right? And which is a little bit bizarre, in my opinion, which is a little bit bizarre because printf doesn't require this kind of education. So I can always just do hello world, then put D in here, and then 69, and I never have to indicate the end of the arguments. Somehow, printf actually figures out the amount of arguments that I put in here. So why do I have to put null in here? Why do I have to put null in here? So there is a fundamental problem with variadics in C, when you're writing a variadic function, you like fundamentally do not know how many arguments are going to be passed in there. You literally don't know. The thing you have to do, you have to pass additional information of how many arguments you have along with the function call. In case of execlp, you indicate that by providing null, because you can only access them sequentially, right? So you can access them sequentially, and as soon as you encounter null, the function knows, okay, so this is the end of the argument, I'm not going to continue processing arguments, otherwise I'm going to corrupt the stack. Right, you can pass maybe a number in here, but I generally found that very inconvenient because you always forget to update that number, right, when you add new arguments, so it's generally not convenient. The question is, how the fuck printf knows how many arguments you put in there? This is because the amount of arguments of printf is encoded in a format string. Right. So printf processes the format string and it encounters $, so it knows that the next argument has to be integer. Right, then it encounters as, okay, so it queries the next argument and then it finishes the process the format string, so it knows that there's no more arguments, so that's why you never have to provide the amount of arguments, because you already do. That's why. This is actually very interesting. You may think that you do not provide the amount of arguments to printf, but you do. You just didn't notice that. The amount of arguments is encoded in the format string. That's how it works. What's funny is that it was not obvious to me from the start. Right? It's really not obvious unless you try to write your own variadic function. As soon as you try to write your own variadic function, you realize, oh, that makes a lot of sense. It's just like, this is the things that we don't really think about too much, right? But they're there. And they actually justify a lot of weird decisions like this, like why do you put null in here? Because there's no other way to know how many arguments you have in here, because this is how C works. Right, and printf kind of does the same thing. So, all right. So let's actually not provide any arguments in here, because one of the things I want to do, I want to literally just run this thing, right? So if I remember correctly, this thing will return like a negative value on an error, just like any POSIX function, right? So here we can say printf and std error, how we're going to say that, could not run ffmpeg as a child process, right? Because of reasons str error, error no, that's the reason, and we're going to exit with 1, otherwise we're going to exit with, that's actually it, right? So essentially, if the child process was successfully executed, everything after that call is going to be completely erased, right? Because the entire execution process is going to be substituted with whatever we have in ffmpeg. So we only can reach this point if return was negative, right? Which is rather interesting, which also means that this thing is unreachable, right? Yeah, this specific place is literally unreachable because you can only like reach here if there was an error, right? If you didn't, yeah, so this has to be set as unreachable, I think. That makes sense. Anyway, alright, so let's try to compile this entire thing and see what's going to happen. So we have a couple of unused things in here, right? So maybe it makes sense for me to put a void in here. It was also complaining about assertion, right? So let's go ahead and do that. Okay, so if we try to do main, right, so it says hello, yeah, so we can't see the child process, and I suspect this is because of the Emacs. Right, because Emacs compilation mode is a little bit weird. If I just run it, yeah, there we go. So if I run it as just like a regular child process, here's what we can see. So what's funny is that we first see the parent, and only then we see the child. So look at that. We run the child first, but the message of the hello parent executed after, right? So, but then here we see the child first and then the message here. And this is because it's two separate processes, right? So it's sort of like a race conditioning situation, right? So because they are running like in like asynchronously, essentially. So one thing we probably want to do in here, we probably want to wait until the child has finished executing, right? So essentially here we executed the child, and we want to wait until it finishes executed, right? So we want to like exit from the parent until the child has finished doing any of the work. So for that, there is a special function literally called wait, believe it or not, right? So it just waits on the PID, right? So this one is rather convenient, right? So this specific variant, it accepts W status, right? So W status is pointed to a variable, and when wait actually exits, it will return you information about what exactly happened to the child, right? What exactly happened to the child. So there's a couple of special macros in here. So this macro will tell you whether the child just exited, right? So this macro will tell you the exit status, right? So essentially the exit code of the child. So there are another things. For example, here, if the child was terminated by a signal, right, whether it was killed, right? So, and also you can get the termination signal and stuff like that. So basically in that W status, there is a lot of information encoded, right? And wait effectively actually waits for any of the changes happening to the process, right? So as soon as some change happens, the wait will exit, and then you will be able to extract that information out of this entire thing. But as far as I know, you can set the W status to null, and basically it will tell the kernel that you don't care about what happened. You just want to wait until the child has changed its status, right? And usually that will mean that it finished executing, right? So that's basically what we want to do. So we want to just wait in here, and here we can say something done rendering the video, right? Something like that. We're not going to provide the child in here, right? But something like this. Okay, let's recompile. So wait actually wants a special header, right? So what kind of headers do we want to include in here? We want to have types and wait, but we already have types, so we don't really need to include that twice. Right, so that's the headers we want in here. And there we go. So if we try to run this entire thing, it is going to have done rendering the video always at the end, because it first waits until the FFmpeg has finished executing and only then prints this entire thing. So everything here is in sync, right? So we execute in the child, and then we wait for the child, and only then we do something with the result. Isn't that cool? Isn't it epic? I think that's pretty freaking epic. Right, so, but if we enable this flag, right, if we enable this flag, that means that we say to FFmpeg that it should expect the data from the standard input. So how can we even now feed that stuff into the standard input of FFmpeg? That is a very interesting question. So first of all, we need to establish a pipe. Right, so we need to create a pipe. What is a pipe? Right, so let's actually search for a pipe. There we go. So there's a special syscall, and here's the pipe. So this is a very interesting function. So we probably want to execute that before we forked any children, right? So somewhere here. And what it accepts an array of 2 elements, right? So this is basically how you have to call it, right? So you call it like that, and of course it returns an integer. And essentially, if it's negative, we have to report an error saying that you couldn't create a pipe, right? Std error, error could not create a pipe, right? Because of some stupid reason. Let's actually print the reason just in case, because why not? Right, and essentially what it does, it creates 2 file descriptors. The read file descriptor, the read end of this thing, and the write end. Right, so, and essentially it puts both of the descriptors into the elements of this array, right? It puts them there. So, and I don't remember which one is read and which one is write. So, creates a pipe, a unidirectional data channel that can be used for interpersonal documentation. Array pipe of D is used to return 2 file descriptors referring to the ends of the pipe. 0 refers to the read end of the pipe, and 1 refers to the write end of the pipe. So essentially everything you write into that end using literally the write syscall. Right, so there is a, this is not really a syscall, this is an external command, right, but what we have to do, we have to use write on a second section in here. Right, so if you write into that file descriptor using this syscall, it will appear on the read end that you can read with the read syscall. Right, so it acts like a file, like a Unix file. Literally. So, and essentially what you have to do, if you want to establish like a pipe between two processes or between two threads or something like that, you just give one end to another process and another end to the first process, and they can communicate through that pipe. Like, and they'll be able to read and write to these things like files, right? Well, it's unidirectional one, so you can only write into one end and read from another one. So there's probably some like maybe multi-directional ones, but I'm not really aware of them because I'm not a programmer. It's like a socket, yeah. So, but as far as I know, socket is like a multi-directional or bi-directional, right? So it's more of a bi-directional thing. This thing is unidirectional, and it's also used like for local things. Multi-directional pipe is called two pipes. Yeah, I suppose you just create two pipes for this entire thing. But what's interesting about the ends of the pipe is that they're file descriptors, just like when you open a file. Or standard input and standard outputs are also file descriptors. So if we somehow replace the standard input of FFmpeg process with the read end of the pipe, we'll be able to actually feed the data from the parent into the standard input of FFmpeg. See what I mean? So we're on the right track. So, okay. So I actually want to maybe create a couple of macros in here so I don't confuse myself. So 0 is a read end. Read end is going to be 0 and write end is going to be 1. All right. And here's the interesting thing. So since we forking and cloning the processes, child in fact is aware of the file descriptors. So we create pipe in here, and both child and parent know the file descriptors of this pipe. Right. And this is where an ability to just prepare something right before actually executing the child comes into place. Right. So you can use this time before actually running the thing to establish the connection with the parent. You know what I mean? Right. So, and this is why it's usually like very important, right, to have that a little bit of a time so we can set things up. Right. So, and essentially, we need to replace the standard input with the read end of the pipe. How can we do that? Well, for that, in POSIX, there is a special syscall called dup2. Right, it's just actually generally like a family of functions called like dup, but the one that we care about is dup2, right? So, and essentially, dup2 accepts two file descriptors, right? Two specific file descriptors, an old one and a new one. So, and essentially what it does, it takes the old file descriptor and kind of reopens it or renames it into a new one. You know what I mean? So I don't know, like, what's the actual wording of the description? Right, so dup2 system performs the same task as dup, but instead of using the lowest number unused file descriptor, it uses the file descriptor specified by newfd. Right, so essentially, it tricks the process into thinking that this file descriptor is actually this one. Right. So, and essentially what we can do, we can say dup2, okay, so what we care about, we need a pipe fd, right, we need the read end of that pipe, and we say, basically, reopen that read end as stdin number. I don't remember which one was that, how is it called, stdin? There was a macro for that, right, so there was a macro for that. libc stdin number. Who remembers? Who remembers the macro? Yeah, I know that you can use 0, 1, 2, but there was a macro that specifically defined. Yeah, file no. Yeah, thank you so much. File no. Yeah, because I keep forgetting, right? So, so I want to work like with semantic names, right? So I could have just like put 1 in there. Right, or 0, I don't remember. And that's exactly why I want to use this thing, because I don't quite remember. It's 0, 1, whatever file, std in file no. Right, so I'm essentially reopening this thing as the input, right? So, and then if this entire thing is less than 0, that means there was a problem in here. Error could not reopen read end of pipe as standard std or something. Not really particularly useful, you know, error description, but it is what it is and it isn't what it isn't. And that should be sufficient actually now. As far as I know, the other thing that people do, and that is kind of important, is that you want to close the right end on this side. Right, because the child doesn't really need the right end. Since you sort of fork the process, the file descriptor is also forked, and since you're not using the right end, you can close it, but it's gonna stay open on the parent's end. On the parent's end, you probably want to actually close the read end, because you're gonna be writing right into this entire thing. Right, so we're gonna do write read end, and then we're waiting for this entire thing. Okay, so now we just need to test all of that. Right now we just need to test all of that. So let's actually enable the standard input, the raw video. Right, so let me actually see. But maybe before we test all of that, let me actually just compile, right, just to make sure that, yeah, okay, everything is compiled. That's cool. Right, so we have to provide the codec. Right, so this is going to be the codec. They're using single quotes, we are using double quotes because we're Chad C developers. Anyway, I'm sorry, I'm joking, by the way. All right. So file format, like pixel format, I think I want to use RGBA 32. I don't know if FFmpeg actually supports this kind of stuff, but we'll find out. Right, so here, I suppose one of the things we have to provide is essentially the output codec, libx 264 or 56, I think that's the codec that you want to use. libx 256, 54, I'm sorry. Yeah, so that's that. Is it 64? Okay, I'm sorry. And also we want to output that to MP4, right? So we want to output that to MP4. So one of the things we probably want to do, by the way, right? So I forgot to specify the size of this entire thing. So let's actually specify the size. The size was S, and let's say that we're going to have something like 800 by 600. So this is how you specify the size. All right, so now we can just try to go ahead and like send all of the data there. So let's actually try to render a single frame. Let's try to render a single frame. So we're going to iterate. Since we have a size 800 by 600, so we're going to have something like 800 by 600 plus I. All right, and what we're going to print in there, we have to write into pipe fd right end, right? So this is going to be right end, and we need to actually provide the buffer. So let's actually provide the buffer. So this is going to be a single pixel, and the pixel is going to be red, right? So this is the red pixel. So we're going to provide the pointer to this thing, and yeah, we're going to write pixel by pixel. It's probably not a particularly great idea, writing all of that stuff pixel by pixel. But it is what it is, and it isn't what it isn't. So let's give it a try. So let's try to build this entire thing. So it doesn't really work. Right, so we need to provide stdint. Right, so this is going to be stdint. Okay, so let's see if it's going to work. Right, so I'm going to just do that. And invalid data found when processing the input. That is very interesting. So, really weird. It's not particularly useful information, in my opinion. So what was it saying? So some people were saying in the chat, I do quite remember, somebody is shooting outside. Well, it is what it is, and it isn't what it isn't. So there's already, the war actually reached Siberia. Ukrainian forces are already deep inside. In Siberia. Okay. So we have to provide the, I think, V codec, right? And let's try to rebuild that one more time and see if it's going to work. Okay, so invalid log level. So that's really interesting. So invalid log level libx. So I suppose that's what have to happen here. Let's actually combine the build and this entire thing. All right, invalid pipe. So there's problem with pipe, right? Invalid data found. All right, invalid data found. That is really weird. So it doesn't like the data that we sent into the pipe. Right, it doesn't like the data. So let's actually find for maybe other things, because that should work. Maybe, is it just RGBA? It could be just, no, it's just that. So let me find, how can I pipe data losslessly into the FFmpeg. Necessary cookies only. Input. Maybe we also need to do FPS, right? So I forgot FPS, so it has to be also rate. So Albert GPT Twitch actually suggests that, so let's actually, let me take a look. RGB24, I don't really want to use RGB24, honestly. I want a RGB A32, though I'm not sure if it's particularly useful, right? So I can do SV. So I think I forgot the rate, but I'm not sure how useful that would be. Okay, so let me see. Invalid data, I'm not sure. So I close that. That is rather weird. Is that because I have to put the pixels? Okay, let's actually introduce 800 by 600, right? So let's do something like that. uint 32 pixels, width, height, right? And let's actually simply fill up this entire thing, right? So this is going to be size t, less than width. And FFmpeg, especially I like how FFmpeg completely useless in that regard. Like, it doesn't really provide any useful information. It's just like, invalid data. I don't fucking know, dude. I don't know. So oopsie doopsie, fucky wacky, you know, the usual stuff. So pixels, this is gonna be I 000 FF, and one of the things we probably want to do, right, so we just want to provide the pixels, size of pixels multiplied by width and multiplied by height. So maybe that's the problem in here. Right, so maybe it doesn't like this entire stuff. Right, still invalid processing data. Alright, so let me see, what could I have forgotten? What could I have forgotten? Read and write video frames Python using FFmpeg. What kind of flags I could have forgotten? Okay. Why everyone uses RGB24? It's not particularly convenient to use RGB24, in my opinion. So vcodec. Do not expect any audio. We can try to enable that as well. Do not expect any audio. So vcodec, we already set this thing in here. Alright, output file. Maybe this is one of the things that could have been useful, right? Overwrite file. The standard input, the format is raw. vcodec that we accept in here is raw, yes. PixFMT, okay, FFmpeg, PixFMT or GBA32. Is there something like that? RGB32. So let me see. Okay, so we can say RGB32. Okay. XFMT. The most annoying thing is that I tried that before the stream and it worked, but I don't remember the flags. Raw frames. Read render raw frames. Render WebM, okay. So we can try to enable logging, maybe. Let's see. What's interesting is that I don't need anything but just the right flags, right? And it's so goddamn hard to come up with the right flags. It's just like, holy shit. Nut. Have you heard about such format? Nut. Nut. Okay, I'm gonna look up, well, maybe not, log level, FFmpeg log level. FFmpeg is so goddamn annoying, like, holy shit. It's just like, it's doing too much as well. It's just like doing too much and it's so obscure. Alright, so FF documentation. Oh my god, it's also super. So raw after input, I don't think it's dependent on this thing. I also remember RGBA working. I like quite vividly remember that thing working. Like I do. Like this should be enough. But it's just like, I don't fucking know, man. Log level. So, oh, I hate FFmpeg. Okay, how do I use that? Log level. Why is it? This is so weird. It's just like freaking. Okay, so all right. So repeat level verbose. Okay, let's enable log level verbose. So invalid data found when processing input. Just a second, I had some notes before the stream. So one of the things I think that we have to do is enable this thing. No. Huh. Something different. Holy shit, something different. What the fuck? Okay. So if you put it like that, invalid data found in processing unit. If you put it like that, it's invalid argument. Fucking, who designed this shit? Like, I'm sorry, just a second, just like I need to calm down. So this is going out of the window. Okay, so this is I think this is not needed. How does that make any fucking sense? Like, why? Why would you design system like that? Why? Why on earth would you do it like that? It's just so bad. But, and of course, I'm being an ignorant idiot who didn't read documentation. Fucking, it's so bad. I'm sorry. Okay. And like, is it really my fault? Like, chat, tell me honestly, me having problems with this piece of software, really my fault? Yes, it is my fault. Yeah, it's just like, I don't even know what to tell. Like, maybe it is my fault. Maybe I am that dumb that I couldn't figure out the right order of arguments. And the documentation is so goddamn obtuse. It's just insane. It's like, dude. Oh, I'm sorry. Like, it's just like every time I work with FFmpeg, I feel how I'm being unreasonable, but at the same time, it's just like, is it me or is that the problem? I don't know. Okay, so I think we're done with this entire thing. Okay, so it can render some stuff, but as you can see, it doesn't really finish processing. Right, so it even generated some outputs and stuff like that. So it keeps doing this thing, right? So it keeps doing this thing. So, and I think one of the things we have to do is close the pipe. Close the pipe. Right, so let's do right, and then wait until it finishes and stuff like that, and hopefully it will generate a single frame. Right, so, and it seems to be, it generated as much video as there is a code in here, right? So let's actually take a look. And did it work? We don't really know. One of the things we probably want to do is maybe generate several frames, right? So who said we can't do that? So we have FPS equal to 60. So maybe what we can do is essentially for this 60 iteration, right? So we can just like write this thing 60 times, right? So we can just write this thing 60 times and it generated like 4 kilobytes, right? So, and there you go. It was 1 second of red screen. So now we can do some interesting shit. Right, so now we can do some interesting scheiße. Right. But before we do some interesting scheiße, I think I want to make a small break. I want to make a cup of tea because working with FFmpeg was extremely stressful. Was extremely fucking stressful. You need to know the right combination of flags. It's not enough to know the flag and what they mean. You have to like put them in the right combination because it's like a password, you know? It's like a code that you have to sort of brute force and you put them in the right combination and the lock clicks and it opens up and it does exactly what you want. You can't just put some flags in there. No, 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 no. There should be a special code and special combination. So, yeah. All right, so let's make a small break and thank you so much Danny's board for tier 1 subscription with the message "Atsodding a pogging." I am a pogging right now. And Paykill1, thank you so much for tier 1 with the message "Fuck FFmpeg, am I right?" Well, to be fair, the creator obviously put a lot of work into this thing. Right, and it is a very useful thing, a very useful piece of software. It's like a very influential piece of software, but the way it's organized, it's like, man, Jesus. And I don't know if that's just generally the software rot, right? When the project becomes so big and so rotted that it's just like impossible to fix all of this problem, or it was intentionally just like misdesigned like that. Like it's really hard to tell. It's like, I don't know, and there's no thing that will replace it. It's like it falls into this like similar niche as curl, right? So it's like very annoying thing to work with, but you just can't replace it because it like feels this like irreplaceable niche, and there's literally nothing you can do, and that's why you have to just like suck it up. You know what I mean? It's like for me, FFmpeg is a curl, but for videos instead of HTTP or other like download protocols or something like that. So they kind of fall for me into this same like roughly niche. So anyway, so let's actually do. Yes. Right, let's make some break and you guys have fun. Alright, so let's try to animate this thing, right? So let's see what we can do. We can actually use Olivettes. I think we should be able to use Olivettes. Let's go ahead and do that. Right. So where is... by the way, for those who don't know, Olivettes is just like a very simple library that I developed quite some time ago. You can find it in here if you're interested, of course. Right, so and for people who's watching on YouTube, I'm gonna put that in the description. Olivettes, right, I'm gonna put that in here. So what it does, it basically allows you to render into the chunk of memory that you allocated, right? So it's a fancy memset, yeah. So let's find Olivettes thingy. Here it is. There we go. And let's take it raw. I love taking my libraries raw. Control F, raw. Boom. There we go. We're gonna download that. wget and just download that raw. What we're gonna do, we're gonna include this entire thing, Olivettes, and we also need to enable implementation. There we go. So let me actually recompile this entire thing just in case, just to want to see if I didn't introduce any fucky-wucky and potentially oopsie-doopsie. So the first thing we want to do, we want to construct the canvas out of the pixels that we allocated in the static memory. So it's going to be Olivettes canvas, canvas OC, Olivettes canvas, pixels, width, height, and width again, because this is a stride. Right, and in here we can do Olivettes fill, and we're gonna fill that with my favorite color, which is 18, right? So this one. And then we can try to maybe render a circle. We're gonna render a circle at the center, right? So it's gonna be at width divided by 2 and height divided by 2. And in terms of radius, let's actually say that the radius is gonna be dependent on the height, and it's gonna be a quarter of the height. Right, and the color is going to be, let's say, red, right? So that's the color, and we just rendered a simple scene into the memory of the computer. Right, and we don't need this kind of stuff. And the next thing we can do, we can just like render that like 60 frames of that, right? We can try to render 60 frames of that. So let's try to rebuild this entire thing, and let's try to run this entire thing and see if it's going to do this stuff. So it rendered something, right? It rendered something. Let's open this video. Yeah, so that looked interesting. So with 1 second is not too much. Let's actually render it for longer. Let's maybe introduce something like duration, right? And let's say that it's going to be 5 seconds. And the duration is basically something like this, right? So we're going to divide it, multiply it by 60. And that way, right, so it's going to like render for a little bit longer. 5 seconds of this stuff. Okay, so let me open VLC, and this is basically this thing for 5 seconds. Isn't that amazing? That's the peak of technology, as the chat says. Exactly, that's the peak of technology. I would like to actually reduce the radius for a little bit more. Let's actually say this is going to be 2 seconds because it's renders for too long. Yeah, flag of Japan, dark theme. Flag of Japan, dark theme. Okay, so let's actually make this entire thing moving, I suppose. Right, so let's make it moving. One of the things I want to do, I would like to have width and height and FPS as the parameters. Right, so we already have width and height as the parameters, we don't have FPS in here. But the problem here is that they're not synchronized, right? So I want to be able to put this stuff in here. So as far as I know, we can create like stringify macro, right? So in C, you can take any expression and sort of like stringify it, if you know what I mean. Right, because essentially there is a very interesting feature. If inside of the macro substitution you refer to the arguments as hash, the name of the argument, it will turn it into a string. Right, so I'm going to show you. So if we return 0 in here, and we're going to try to print something like str FPS, right? So let's give it a try. It's gonna give you like literally FPS, but we want to actually render the value of FPS as a string. For that, there is a very stupid hack, right? In C, you have to do that in two levels. Basically, you have to introduce str2 that does that, and inside of str, you have to call str2. You have to forward that thing one more layer and do it like that, and only then it will take the value and render it like this. So yeah, this is because of this substitution bullshit stuff. Right, and that will allow us to essentially take the FPS, which is a number, right, and just like put it like this in here, right? So, which is rather convenient, right? So this will allow us to do this kind of stuff. But the problem is that in case of width and height, we have to combine them together into a single string literal. And here we can use another C string. We can use another C string where if you define a string literal like this, this is a single string literal. You may think this is two string literals, but this is a single one, believe it or not. This is a single one. So let's actually go back to our experimentation, and I'm gonna do something like this. And what if I do hello? Right, what if I do hello? It will just print you hello. But then you can literally put a space, no comma, just space, and it will print you hello world. This is a valid C, by the way. For those who never worked with C and C++ and stuff like that, this is a valid C. Perfectly valid C. And this is because it allows you to have a single string literal on several lines broken up like that. This is still a single string literal. This entire thing, a single string literal. Believe it or not. You may not like it, but this is a peak of syntax of programming, which actually allows you to do a pretty cool shit. So essentially, we can do str width, right? We can do str width. But this thing, from the point of view of the compiler, is a string literal. And since we can combine string literals like that, it allows me to do something like this. And this is a string literal known at compile time. Without any memory allocation, without any concatenation or any bullshit, I just constructed concatenation of two values known at compile time into another value known at compile time. So that's basically what you can do in here. Yeah, so C is one of those languages where it seems to be simple on the surface. It's a very simple language. But there's always something you discover about this motherfucker. Like seriously, it seems simple. You can like program in it for decades, and once in a while you're gonna discover shit like that. It's just like you never stop learning, even though it's simple. It's just like always some new weird shit that pops up. Right. So, and it's not even C++. I would understand that this would be C++ because you can learn C++ indefinitely, right? So it's just like an infinite complexity. This is pure C. No bullshit. And still, you can just like discover some weird stuff about this language. This basically allows us to put this thing in here without any dynamic memory allocation. It's quite important to remember. No dynamic memory allocation. This entire thing is literally constructed at compile time. Right. So that's what's interesting about this. So that means if I at some point want to render at full HD, I can just do that. So we can render at full HD in 2023. So who said we cannot do that? We can do that. This is going to be full HD. And rendering 5 seconds of full HD is kind of difficult. Especially when I'm streaming. It's just like, right. So let me see. Yeah, this is full HD. High definition circle. That's absolutely poggers. Anyways, so let's actually define the position of the circle. Right, so let's define the position of the circle. The circle is going to be positioned at x, which is width divided by 2, and y, which is height divided by 2. And we probably want to render each individual frame on each iteration as we just, you know, feed them into FFmpeg, right? And every time we render them, we want to be using the current position. So this could be actually extracted into a radius, right? So we can put it as a radius in here. There we go. And we probably want to introduce the velocity of the circle, where it is moving. Let's say it's going to be moving at 100 by x and at 100 by y. Right. So if we want to animate all of that properly, we need to know delta time, right? So since we know FPS, right, so we can quite easily compute the delta time based on the FPS. So, and every time we render everything, we want to update the position of the circle, basically add dx, right, but multiplied by dt. Right. So dy dt. So and that will essentially move it by like diagonally and stuff like that. So let's try to render this entire thing and see if it's going to work. So we probably want to reduce the resolution because 60 FPS at full HD when I'm streaming as well. See, it's kind of difficult for this entire thing. So, but it's supposed to be moving. It's supposed, yeah, and it is moving, right? So it's cool. It's pretty cool. Okay, so let me reduce the resolution by this, and maybe I want to reduce the FPS to make it a little bit faster. That should allow me to have a higher duration. What about 10 seconds? I'm pretty sure I'll be able to manage to render 10 seconds of this entire stuff relatively quickly. No, even 10 seconds is a little bit difficult for this thing to do. So it seems to be, yeah, it actually generated more, I think, but maybe, I don't know. Let me see. Oh, it was 20 seconds. Ah! This is because I'm referring to FPS here directly. So this is the danger of hard-coded magical numbers. Right. So we're gonna do FPS. All right. So let me see. Okay, so that should be faster because we're rendering precisely 10 seconds. Okay, no. So let's quickly make it bounce like off of the walls. So that should be pretty straightforward. Right, so instead of like straight up adding this entire thing, what we're gonna do, we're gonna save it into an intermediate variable, right? So we're gonna save it into an intermediate variable. And one of the things we wanna check in here, if it is within the boundaries, right? If it's greater than 0 and less than width, that means it's a valid next value, and we're gonna assign it to the current thing. If it's not a valid, right, if it overflows like left or right, instead of like assigning and committing to that value, we're gonna be basically inverting the x. Right, there we go. So basically we try to step in that direction. If we can't go there, right, because we like reached the wall, we're not gonna go there. We're gonna invert this velocity and try in the different direction on the next iteration. So that's basically how we bounce off of the wall. Right, and this thing kind of implies that the circle is gonna go off of the, like out of bounds, and it's only the center that is going to bounce. So usually it's countered by subtracting the radius, right? So we're going to subtract the radius in here and add the radius in here. And we repeat the same thing for y as well, literally the same thing. right, if it's less than y and y less than height. Right, so here I want to subtract r or add r, and if everything's okay, I just commit to that specific position. Otherwise, I just don't do anything, only invert the velocity, right? So, and maybe I want to render for, let's say, I think maybe 10 seconds gonna be fine, but let's make it a little bit faster, like twice as fast. So this is gonna be 2. There we go, because we want to see how it's gonna bounce off of those things. All right, so yep, it is bouncing. I'm not sure how well you can see that, but it is bouncing off of the walls. Yeah, and that's the video we generated. It's 10 seconds of this thing bouncing around. So that's pretty cool. So that means we have the technology to render the videos. We have the technology. So the only thing that we need to do with that technology is to merge it with the neural networks, right? So now we have to go and just like generate a video out of the neural network. So let's go ahead and do that. So let's go to the, I definitely need to save this specific project, right? Because yeah, I want to be able to people to reproduce this entire stuff without fighting with FFmpeg flags, right? So yeah, let me actually quickly do that right away. So I'm gonna create it under MIT license. You can do whatever the fuck you want with it. I'm gonna put a README in here. So in terms of README, what we're gonna have. So how we're gonna call this kind of thing? So rendering video in C with FFmpeg, right? With FFmpeg. So in a quick start is essentially so console, so you just build this entire thing, and you just run this entire thing. There we go. So, yep. And then you can customize all of that. So the whole program is very simple. So it's very obvious, like what you can change in here, how to customize all of that, and everything. So yes, maybe I want to git ignore some things. I'm gonna definitely git ignore MP4, right? And another thing we're gonna ignore is main. Right, and let's do git init like so, and let's do a committee. So ready, set, a go. So the only question is how do we want to call this entire thing? So what would be a good name? Rendering video with C, in C with FFmpeg. So we can just like literally call the whole project like that, because I don't plan this thing to have like a catchy name or anything like that. I plan this thing to be just an example that people can copy paste and start building their own stuff on top of. How do I English? I don't know. So I'm gonna just give it very explicit name. Rendering video in C with FFmpeg. Right, so that's gonna be literally the name of this entire thing. And let's create a repo for this entire stuff. Because also it will make it easier for people to Google up this thing, right? So because somebody may want to know, like, how do I do specifically that? And it's going to match the keywords that we put in the name, and it's going to be actually helpful, right? So no bullshit, right? So that's why I don't want to give it like a sort of like catchy name or anything like that. Right, so I don't think it's useful for that specific case. Right, so this is going to be public. Alrighty, so let's copy paste it, and it's going to be useful for me in the future as well, by the way. Speaking of, alright, maybe at some point I want to be able to do that again, and I don't want to be fighting with the FFmpeg flags again. Right, I want to solve that problem once and for all and forget about it. Especially in this specific case, because when I'm rendering these things, what I want is just to like inspect something, right? Some algorithm or some other things or whatnot, right? So I don't really need a very specific video format or anything like that. Right, so I'm gonna copy paste it in the chat, and for people who's watching on YouTube, I'm gonna put it in here, right? So this is how you can render a video in C with FFmpeg if you ever wanted to do that. Right, so that's a very like a simple proof of concept that you can just compile and play with, and there you go. All right, So what we need to do, we need to integrate all of that into our neural network thingy, right? So let me go to nn.h, and in here, I suppose I'm gonna start copy pasting. Okay, so we probably want to generate a video when we press a key, right? So we have a section in here when we press space, it just toggles the pose. When we press R, it resets the training of this entire thing. When I press S, it creates a screenshot of upscaled version, which is actually a pretty big amount of code. So maybe I want to factor that out. Right, and we're going to have something like is key. What kind of key we're going to assign to rendering the this entire thing? So maybe it's going to be X or something like that, right? So maybe something like X. So and then we can say render upscaled video, right? Render upscaled video, and we will need to just implement this function. This function is probably going to accept the neural network itself, right? And we'll see, maybe it will need more parameters in here, but for now it's going to accept just the neural network. Right, so it's just nn, there we go. So so I also wanted to factor out creating this screenshot, right? Render upscaled screenshot. Right, so we're probably gonna provide nn, and let me factor out that thing in here to render upscaled screenshot. Super quick. Yeah, I think I can just do it like that. So I'm not sure if it's going to work, right? So I'm not sure it's going to work, but I'm gonna just go through the compilation errors and fix everything. Right, so let me rebuild this entire stuff. So probably also want to do opt ready.env. So this is gonna be the dot. So let's see. So probably don't want to build everything, right? So let's not build everything. Let's comment out some of these things. I hope it's not going to bite me in the ass. So here we have to provide out width and out height, right? So this is out width and out height. So I provided them in here, right? So this is out width and out height, and I also constructed this entire thing. So what I'm thinking is that maybe I need to put that stuff into the static memory, if you know what I mean, right? So I think it should be, yeah, it should be in a static memory, because I want this thing to be available like everywhere. So out width and out height, and here we can just simply construct something like this, right? So it's going to be out width multiplied by out height. So the main problem in here is that it accepts uint8 instead of uint32, right? So that means we'll have to, yeah, we'll have to do something about that. So and I'm definitely going to be reusing this buffer for render upscale video too, right? So since basically these two functions do the same thing, it's just the upscale video does the screenshot multiple times, if you know what I mean, right? So yeah, so let's go ahead and do that. So here you cannot construct it like that, so which means that this thing has to be a macro, right? It has to be known at compile time. So let's make it known at compile time. Sure, I don't mind that. So what do we have in here? Expected what? Oh, this is because goddamn C, what can I say? Okay, so here we have to accept the NN, the neural network that we're currently rendering. What else do we want in here? Okay, so here it may fail, by the way, right? It may fail, so we have to return integer. There we go. And here it's going to be 0. So I suppose if it failed, right, if it failed, we probably want to return 1 here as well, right? So here, in case of success, it returns 0, right? Otherwise, yeah, so essentially we want to probably chain that, right? So this thing basically logs everything, so we don't have to do that. So image file path, so Do we want this logging? I don't think we want this logging. This logging was introduced at the beginning of the development of this thing. Right, so, and it's not really relevant because we actually generate from 2 images. In the future we may have several of them, so this login is not particularly relevant anymore, in my opinion. So here we also do upscaled PNG, which could have been also maybe provided in here. Const char out file path, right? So then we don't really have to do that. Though in terms of generating, by the way, we could have said something like generated as which is out file path, right? So that's one of the things we could have done. So, and in here we have to say upscaled PNG, right? There we go. Seems good, seems Gucci, seems Tamaguchi. So we got some subs. Let me quickly acknowledge them. So Volk TV, thank you so much. Volk TV, I suppose that's how we're supposed to pronounce it. Thank you so much for Twitch Prime. Thank you, thank you, thank you. All right. Okay. So now everything seems to be okay, everything seems to be working. The only thing we need to implement now is upscaled video, render upscaled video. So let's literally copy paste our solution, right? So we're going to be creating FD. This one is rather interesting. At the end of the rendering, we close both of the ends of the pipe, so everything seems to be like finished, right? No cleanup is required in here. Okay, so I suppose for this entire thing I can just copy paste this entire stuff, right? So we just copy paste it in here. Then we're gonna have some rendering in here. I'm not gonna copy paste anything yet. Then after that we're closing this entire thing, right? So to do render the neural net, right? So this is where we're going to be rendering all of that. So, and here we want to say something like generated s, right, which is going to be out file path, and we're going to accept that out file path in here, right, out file path, and we can even put it in here, out file path, as we generate this thing. Okay, this one is a little bit annoying in my opinion. This one is a little bit annoying. All right, so there is a problem, as already said, that we have single byte pixels, right? But we want to render with 32. So you know what I want to do? Since it's an output, right? Since it's an output, we can actually just switch to 32, right? That will break a screenshot, but in case of a screenshot, when we're rendering this entire thing, we'll have to construct the pixel properly. How can we construct it? So we can say that this is going to be the brightness. God damn it. Bright. And the actual pixel in here, UN32T, is essentially, well, so this has to be 32. Okay, so there is some problem in here. This value, this is the output from the neural network, right? So we basically made a very wild assumption in here that is going to be from 0 to 1, which is not 100% true. It could be, well, to be fair, it's kind of true because we're using sigmoid, and sigmoid ensures that it's from 0 to 1. But if we change the activation function, this assumption will break. So we have to be super careful with here. So this is activation, right? So this is basically an activation. Right, and what we want to do, we want to make sure that the activation is between the 0 and 1 for this specific case, right? So at least. So we want to clamp it. If it's less than 0, we're going to say it's 0, sorry. And if it's greater than 0, greater than 1, is going to be 1. So we just basically clamp this entire thing like so. And only then it is super safe to do something like this, right? And it's not going to overflow to 155. So after that we have to construct a pixel, and the pixel is going to be FF000. So basically we set up the alpha to be just 255, and then what we have to do is just bright, just like this. So this is going to be the red thing, and then I suppose we need to combine it with green, and then the last one is going to be 16. Right, so something like this. That's probably what we want to do in here. And that way it's going to be the thing. What's interesting is that this is the code that we can reuse for both render upscaled screenshot and render video. Yeah, because as I said, it's rendering video is basically rendering screenshots, but 60 times per second, right? So we may want to factor out this thing. So what this thing does, it actually iterates through all of the pixels of the output and asks the neural network what's the brightness of that pixel, right, and puts it into the image, right? So it renders the single frame out of the neural network. It extracts the frame out of the neural network, right? Is there already capability to save the train model? No, not really, but it's super easy to implement, so I just don't really rush into implementing it right now because I don't really need that, to be fair. But it will be kind of useful to have. So because essentially you may pre-train some model and you may want to save it and then load it up and continue training, maybe even on a different data. And I think this is called like fine-tuning, isn't it? Right, so when you train the model and then you want to specialize that model on some very specific data, right? So you take pre-trained model and continue training it, but in a different direction slightly. So yeah, that would be useful for that specifically, if you know what I mean. So maybe we can try to, like, you can pre-train model to interpolate from one image to another, and then you can take that model and train it to have a very specific in-between frame at 0.5. So fine-tune it to be like that, which is an interesting idea actually. Right. So we've got some subs. Thank you so much, Nick KYR. Thank you for Twitch Prime. Hello, Mizi. So there we go. All right, so let's actually factor this thing out. And I can say something like render single out frame, or maybe out image, right? So, and in here we're gonna accept the neural network, and let's just simply copy paste this thing in here. But we also have to accept the value of the interpolator. So here it's called scroll. Right, let's actually call it something like float A, right? I don't know how to properly call that, but anyway. So when we are doing the screenshots, we wanna render whatever we have in the scroll, the value of the scroll thingy, right? The value of the scroll thingy. So we just render it once, and then we are saving those pixels into PNG, and everyone is happy. In case of the video, we want to be constantly calling to this function, right? To this function with a different A, with a different interpolator. Right, so that's what we want to be able to do. All right, so here we started this entire thing. The real question is going to be, what's going to be the duration in seconds? We can accept the duration in here, duration, and it's going to be float, right? So that means we need to create like a frame count, right? So we're going to have a frame count, which is basically FPS multiplied by duration, but then we have to truncate this entire thing. But I think converting from float to size t is going to truncate that automatically. So anyway, then we want to just iterate through each individual frame, right? So this is going to be frame count. And what's going to be the A for that specific frame, right? What's going to be the A? Well, it is going to be essentially frame count divided, I divided by frame count, right? So we're interpolating from 0 to 1. So here, maybe we want to actually do a float in here. So there is a little bit back and forth conversion between integers and floats in here. So maybe it would be nice to have a float in here, but we then need this thing to be, it's kind of weird. So I think I'm going to keep it like that. Right, so then what we want to do, we want to render, not really that, but we want to render a single out image, right? So let's put it in here. but it has to be A. And I don't think we need A for anything else, so I think I could probably inline it for more expressiveness. And after we render this entire thing, what we have to do, we have to save that thing into the right pipe, right? So we're going to be doing out pixels, size of out pixels multiplied by, we can do it like that, out width and out height. There we go. And that's it, believe it or not, that's the entire thing, right? Since we actually factored out the code that renders the frame, we can just reuse that code in both of the places. And that should be enough, I think. So this is that. This one is a little bit fucky-wacky, that's for sure. Because here we have to use out width and out height. Okay, so in case of FPS, it may work because FPS... Wait a second, out width and out height are already it will work. It fucking will work. Okay, so I thought they're runtime values, so they're already compile time values. Okay, so that's fine. So the only thing we need in here is just this bullshit, right? So let's actually bring it here. So this is going to be 30 FPS. Which is fine, I guess, which is fine. Let's try to build this entire thing and go through the compilation error. Okay, so this is the pixel, and what you don't like. And oh, it's unused. Thank you so much. Compiler actually found an error. And now we have to bring in all of the POSIX bullshit in here, right? So we need to include all of these flags in here, right? Because they're important, which makes this entire thing uncompilable on Windows. And maybe I'll have to put some flags in here, right? Essentially, if you're on Windows, just don't include that feature. That would have been useful, I think. Right, so what do we have in here? Error no, so that means I need to include error no and maybe even string, right? Some stuff like this. What else do we have in here? Return 1. Okay, so this entire thing may fail. Right, do we even call this thing? Yeah, we call it in here, right? So return 1 if it failed rendering. Though, to be fair, you know what? If it failed rendering, do we really want to crash the entire thing? I think it's not reasonable to crash this entire thing. Let's actually ignore this error. We have an opportunity to catch it, but I don't think it makes sense to do anything there. So read end and write end. Let's actually bring these things here as well. Right, so all of these macros that we developed in here, we're slowly integrating whatever we wrote into the thing. So too few arguments. Okay, so single out image, right? And you're supposed to provide also a neural network, right? So I provided only interpolator, but you're also supposed to provide neural network. What else do we have in here? So here we have to return 0. What's the next error? Render single, yeah, that makes sense. What else? Okay, so upscale video. So what do we provide in here? We provide the duration and output. So we want to play the animation. For how long we want to play the animation? So I think 5 seconds maybe is going to be all right. Right, so 5 seconds, let's say 5 seconds. And output is going to be upscaled MP4, right? As you can see, in case of the screenshot, we do upscaled PNG. In case of the video, we do upscaled MP4. All right, so that makes sense, I suppose. I guess it worked. Okay, so let's try to run it and see how miserably it fails, right? So where's my MNIST database? MNIST database. MNIST database. I think I want to actually interpolate from 8 to 6. Right, so training 6. Boom. Okay, guys, let's keep training. Let's train this mother flipper. Okay, so it is training. It is framing. Okay, so it's going a little bit crazy. I'm going to reduce the rate at which it is training. So I don't like this part, right? It's a little bit under trained, I would say. I would let it train a little bit more. Okay, let's take a look at S. Right, so upscaled PNG. What the fuck is this scheisse? I think I know what the fuck is this scheisse. So screen, and we already found a miserably failed thing. So screenshot, where is a screenshot? I think I know. Yeah. Huh. Though, the amount of components has to be 4, I suppose. Right, so here we provide out width, out height, the pixels, the amount of components, the pixels, and the stride. So that's basically the main problem in here. So let me double check that by going into third party, image right, and I just want to see the signature. Yeah, it's amount of components. Okay, so we found a bug. That was important, I believe. All right, so let's try to recompile that one more time. One more time. Oh, Provod, what's up? What's up? What's up? Hello, Mr. Provod. How are you doing? I'm not sure if you're still watching. Maybe you just raided me and left. But hello, hello. Really glad to see you. So we're training some neural networks. That's right. I'm just like training neural network that is going to steal my job. Right. So I'm a streamer. This neural network is going to generate streams for me. Actually, it's not going to take my job. It's going to do the job for me. Right. So because I own the neural network. So that's even better. Let me just do a screenshot just to see what the fuck is going on. So where is upscale? Shit. That looks good. That looks good. That's precisely what I want you to see. Let's reduce the training rate because it's going too fucking crazy, mate. Right? Yeah. I'm manually adjusting the learning rates. I'm training this shit manually, right, with my bare hands. Okay, so let's take a look at the upscaled version of this thing. Okay, this is the 8. This is the 8. And let's interpolate this thing to... This is a good interpolation, right? This is a very good interpolation. Let's take a look at how it looks like. Okay, so looks very good. I think the video is gonna be awesome, right? Like a possum. So... let's get ready. We are rendering the video. That is actually going rather slow. Okay, so it rendered a single second. So we said we're gonna have 5 seconds, right? So, okay. Maybe I should reduce the size. Well, but I mean, I want you to see it in like a very good quality, if you know what I mean. All right. How are you guys doing? How are you guys doing? Why is it so slow? I don't know. I'm probably because I also streaming. Right, so streaming also consumes resources. Okay, so it finished rendering the video, and we are about to witness how like this thing is going to transition from one thing to another thing in a higher resolution, because here we're not doing like higher resolution because it like takes too much resources, right? So so let's take a look. I'm a little bit nervous actually. So are you guys ready? Let's go. This is so cool. It's like a smoke, right? So you won't be able to see that in here in a low resolution. So this is basically this, but in much higher resolution. Much higher resolution. So this is basically a neural network learned how to behave like this image. And then basically we train it to behave like both of the image, right? With the third parameter, which is interpolator. Right, and then when you put something in between 0 and 1, it starts to behave like 8 and 6 simultaneously, so you can interpolate this thing between two images in here like that. I think it should maybe wait a little bit, right, so like a couple of seconds. But yeah, that's actually pretty cool. Perfect loop, yeah, it would be kind of nice to make a perfect loop out of that. Movie needs extra padding at start and end, so 8 and 6 for a while before. Yeah, that's true. That would have been 100% true. And the question is, how can we organize all of that? Right, essentially. So let me see. Render upscale video. Looks like OG YouTube video intro. Yeah, so what's funny is that we generated like this whole video. Let's just think about it. We generated this whole video by using two images. By using just two images from NIST database. This is the first image. You can't even see. This is how small it is. It's 28 by 28 pixels, right? So this is the first image, right? And the second image is 8, right? So, and this information was enough to generate that video, right? So we just trained the neural network to behave like these two things. And then once we build this model, we are able to change parameters of that model and achieve this kind of effects. What happens if you extrapolate from those images? That's a very interesting question. One of the things we can do is maybe... So that requires like too many modifications, right? So yeah, it will be interesting to see what's beyond 0 and beyond 1, if you know what I mean. So yeah, let me see. I want to kind of make this thing loop, right? I want to kind of make it loop. So where is the render upscaled videos? There we go. Here it is. So we have some sort of interpolator. Right. So it's a value from 0 to 1, right? So for now, we're just moving it directly. One of the things we can do, probably, is just do easing in, like easing out. That would have been interesting. So let me also make a resolution a little bit smaller, maybe 256. Probably not gonna look that good, but yeah. So OPT array leap environment build.sh, there we go. All right, so I don't really like this thing, so let me restart. So the cool thing is that I can always restart, and this is where having like an ability to save the trained neural network. Look at how it actually figured out this loop as a separate thing. It's actually fascinating. This is a cool transition. What the fuck? This is a very cool transition. Look at that. This is the coolest transition it came up with so far. What the fuck? Okay, let's render this thing. It goes a little bit faster, I suppose, because I reduced the resolution. Unfortunately, I should have actually done that in a separate thread so I can keep playing with this thing. Look at that fat 8. That's so cool. Anyway, so it should now act differently because I'm doing easing out, because it's like a square thingy. Right, so let's see. There should be, I know that there should be some padding, like, yeah, so chat is gonna be screaming at me, Zozin, there needs to be padding, you don't understand. I mean, somebody has to implement it, calm down, okay? All right, I understand, right, but it's something that needs to be done, right? And people who are screaming are not doing that. It's me who's doing that. Okay. So let me see. I need to think how we can achieve all of that. So essentially, we want to be able to say, right, maybe we will even want to have some sort of like splines, if you know what I mean, right? Some sort of like splines where we can say the following thing. So where is my paint? Where is my paint? So here we have time. Right, so this is time. And here, the value of interpolator. We want to be able to literally like define points like this. Okay, from here to here, right, so the value is going to be like that. Then we want, like from here to here, we want to interpolate like so. right? Interpolate like so. Then from like maybe like wait a little bit, right? Then we want to interpolate like so. And that's basically it, because this particular maybe even duration, let's call it d, is going to be the same as this duration, right? And maybe it's going to be the same as any of this duration, right? So we can basically divide all of this stuff by equal intervals, right? So we want to do something like this, right? So, and essentially we have to divide the whole thing by 4, right? So we divide the whole thing by 4. And then in here, right, we can basically define a structure with a pair of numbers, right? A structure with a pair of numbers which tells you basically from which to which you have to go, right? So that sounds like a plan. So, and that way you'll be able to control like how exactly you want to do all of these things. Right, is it called splines? Right, I think it's called splice. Sort of. How are we gonna organize all of that? So we need a structure. I wonder if I can define structures like this. Let's call it segment. All right, and essentially you have a start and you have an end of the segment, right? So that's basically what we want to have. And so we're gonna basically assume, right? So the whole system is going to assume that you have the segments are equal interval, right? So they have equal intervals. Segment and segments. Right, so, and basically that's what we have. So the first segment starts at 0 and stays at 0, right? So then the second segment starts at 0 and goes towards 1. Then this one stays at 1 for the entirety of the whole segment. And then this one goes from 1 to 0. Yeah, this looks like a binary counting, but yeah, anyway. So now we need a segment count, right? So segments count. How many of them do we have in here? So it's actually, I think I already have array length, so I should be able to just do something like segments, and there we go. So based on the segments, we can essentially compute the segment duration. So let's assume that our entire duration is 1 second. Right, it's basically from 0 to 1. So that means we can say segment length is going to be 1 divided by segment count, right? Segment count. So why are we doing all that? The reason we are doing all that, because it allows us to do something like this. We take the current A, which is interpolated from 0 to 1, which tells you this is the percentage of the video, right? So from 0 to 1, the closer you are to 0, the closer you are to the beginning, and the closer to 1, the closer you are to the end, right? So we can divide by the segment length, right? And the integer part of this division tells you what segment you're in, right? So, and essentially after doing like a little bit of a floor and converted that to the integer, you will be able to just use that in the segments, right? Segments, and that's the segment you're currently in, right? That's the segment you're currently in. Okay, so we can maybe save this entire thing to something like segment index, right? So this is the current segment. So, and how far you are in within the segment? I suppose the fractional part tells you where you are within the segment. Is there any function in C that tells you the fractional part of a floating point number? Because I know that in assembly there was something like that, right? But there should be something in C, right? C get fractional part of float. There's one. Okay. Fractional part. Fract. There should be something like fract. Maybe modf also is going to work. Modf. People suggest modf. Okay. Third alternative. Subtract florf. Okay. So I guess we can just do modf. I guess we can do modf. So how can we call that thing? Right, so if we just do modf, fmodf specifically, of a and segment length. So this is a basically segment progress, right? So segment progress, right? And essentially, what we want to do, we want to interpolate from that value, right? So yeah, this is the segment index. Then we can take the segment, right? Segment index. There's that. So then we can do segment end minus the segment start, right? And then we're multiplying that by the segment progress, right? And that basically interpolates that value from start to end only if we add start in here. And that's the final value that we have to put in here, right? That's the final value. So let's see how it is going to work. So let's call it B, maybe. Right. So this is going to be B. And we can also do like a square thing here, right? Why not? So yeah, that's the way to do that, I think. We'll see. One of the things we can do while we're rendering this entire stuff, we can render the value of B, right? So because I want to be able to see how it just goes up and down. Why the square for easing in and easing out. So essentially, right, so you have a value from 0 to 1, right? So you have a value from 0 to 1, and it maps to a value 1. So initially, if you just like use B, you're gonna have something like this, right? You're gonna have something like this. If you multiply it by itself, right, if you take a square, it's not gonna be greater than 0. It's still gonna be from 0 to 1. But then it is going to have a shape like this, right? It's gonna start slow and then speed up at the end, and it will just look better, hopefully. You can also use square root, right? You can actually use square root. In that case, it's gonna look like this. And I think square root in here specifically could be better, right? Because in here, yeah, this is a square root actually, so we probably want to use square root. And in here, we go from 1 to 0, so that means, yeah, we probably want to use square roots in here. So thank you for asking that question. That actually forced me to draw that and realize that the square is not exactly what I want. I think I want a square root. Right, so and in here, it's going to, yeah, it's going to be inverted. So yeah, so this is going to be square root. So, and here's an interesting thing. That implies that you can plug in different functions in here. And it is a thing, in fact, in animation, right? So is in, is out functions, right? So it is in fact a thing. Right, so is in functions, yeah. So there's also cheat sheet. So yeah, there are different websites that demonstrate you how they feel and how they behave. Right. So I remember this website. So you can basically, yeah, you can like navigate here and play with this entire stuff. So I'm gonna actually put this in here. It is a very common thing in animation. Seriously, it is a very common thing. And I'm gonna also put that in the description, right? So this is gonna be easing.net. Oh yeah, I suppose we can do 1 minus the square. Yeah, because they're, yeah, so we can save a little bit on. So essentially the chat suggests, so, I mean, we need to say the nickname of a person who suggested, but they have this nickname. So yeah. Anyway, thank you so much. So essentially, since we have values from 0 to 1, we can just do something like this, right? So we're gonna achieve the same thing, right? So, but we'll see. So I just want to first see if it's going to work or not. Right. Couldn't apply it with sigmoid. Not a bad idea either, actually. Right. Isn't our really important thing if you want to make animation feel more natural? Yeah. It is true. It is 100% true. Flortf? It's not a flortf. Segment count. Segments count. Okay, so we need to go through compilation errors. And this is not flortf either. It's florf. All right, so let me see. So all right, so is it going to do the thingy? All right, so let's actually slow down the thing. It's actually stuck a little bit in here because of this little tail. Can't really go any further. Let's actually restart. Sometimes it finds like a really weird configuration. Could you just tell the loops generate extra less frame by feeding more or less same similar values through activation? I guess, I don't know. But I want to achieve a very specific result. And I want to have like a control over that result as well. Okay, I think this one could actually work out. I don't really like this this sort of little tail. Right, so if we take a look at that. Yeah, it's kind of bizarre, like, yikes. Well, we can like just keep training it for a little bit more. Maybe it will get rid of that connection in here at some point. It's going down, so it's slowly getting rid of that. It's still there. I don't like it. One more time. It's just like with anything related to machine learning, just try again, just roll the dice one more time. What the fuck is this shit? We're so unlucky today with training. It still creates this connection. I mean, this time it's a little better. Yeah, it's already better. I think we can stop here. This is a good result. I really like it. Yeah, this is a good one. Okay, so let's run it. Okay, as you can see, this is the frames, right? So this and it goes up. It stays at 1 for some time, and then it goes down. Cool. So, but it was weird. That is sus. What the fuck? It didn't go fully down. Alright. Okay, so... Well, let's see how it looks like. But that was truly sus. This is the sussest thing I've ever seen. Yeah, invert square root horizontally. Okay, so... Yeah, because I see what's going on, yes. But that actually implies that I have to literally put different functions in here, and this is something that I don't want. Okay, let's actually not fuck with functions. Right, let's just like use them like this and hope, right, that is going to work out. I may add different sort of easing in and out functions a little bit later. Why is it important to control the learning rate? You don't really have to, but if you don't, it just like becomes too crazy, and I'm a little bit afraid that it's gonna go off track too much, right? Because here it's like calm, but here it just goes too crazy. I just wanted to reduce its craziness a little bit, and it just like goes fine. You know what I mean? Scene might work out nicely, yeah, it's true. So usually like learning rate is controlled like automatically, but they just decided to make it manual because it's kind of like nice to like adjust as you see, right? Just to play with this thing to get the gist of them. If you know what I mean. Okay, so let's render this thing. I think it's going to work fine. Shouldn't the learning rate be very low? Yeah, it should be, but we're using sigmoids, so with sigmoids it's kind of fine. It doesn't go down fully. What the hell is going on? Am I crazy? Why doesn't it go down fully? Did I make a oopsie doopsie somewhere? Don't tell me I did an oopsie doopsie. I genuinely don't see. Could it be because it overflows? Yeah, what the fuck is going on? Didn't it go up? Alright, so here is stuff from 0 to 1. So here we have these things. This is array length. Yeah. So weird. Okay. Let me think. So, this should be fine. Then we do floor. So that gives us this segment, and the segment should be fine, I think. One of the things we can do is that if segment index is greater than the segment length, right, for whatever reason, we may want to bring it back to segment length -1, right? And then, so it doesn't overflow for whatever reason. So in here we do fmode, so which tells us the segment progress. Right, and within the segment progress, right, so we just do this thing minus this thing, we multiply it by that. So then we put b in here, and we just say So I think I want to also print the segment index, right? The segment index, right? So index progress and b. The progress has to be f. Segment index index segment progress b. All right. So I don't think we need to train anything, right? So because we are troubleshooting the rendering process, so I can just try to render whatever we have in here. So index goes up, and it stays at the same index. Yep. I see the problem. It stays at the same index. Okay. So segment index stays the same, even though segment length. Okay. So let's take a look at the segment length. Right, because I would expect it to work, and yeah, floor has to be like a whole part. I mean integer part. I think it's called integer part in here. So let's say segment length and actually exit 1 in here, right? So because I wanted to just stop and don't do anything, because that's the only value that I want to observe in here. So undeclared segment length. Makes sense. Okay. Why? because I'm pretty sure, right? So if you have 15 divided by 25, you have something like this, right? Then you have 25, it's 1. If it's bigger, yeah, it makes sense. The bigger it is, right, the more it should be fine. But it never here in this specific case became greater than 0. This is extremely weird, right? So it should work. It may not work only if the A is not what I think it is. Right, so this is the only reason why this won't work, right? Segment length index is greater than segment length. No, what the hell are you talking about? I don't know what you're talking about. All right, so all right. Yeah, so at this point, the index has to be greater than, it must be, there's no other way, but it just stays the same. Is that because of the floor? Right, so A is a float, segment length, It could be weird floor thing, but I refuse to believe that it's a weird floor thing. No. Is that... Don't tell me that's the reason. I'm gonna be extremely disappointed. Oh, I think I see what the hell is going on. That's what I want. Yeah. God damn it. Okay. Segment count. Okay, we found it. I think we found it finally. Holy shit. Alright. Yeah, finally. Okay, it works. It works. Alright. Okay, guy. Alrighty. So, let's go ahead and try to train this thing. So I'm gonna redo it one more time. So first let's come up with an interesting animation. Right. Let's come up with an interesting animation. Okay, let's do a little bit of snapshots. This is not what I want. Okay. So what about 6? It's having this Emacs, come on. Yeah, it's still having this thing in here again. But whatever, let's actually train it anyway. Alright, it's going places. Then it should be going down. Did I... Why? Why it didn't do? Why didn't it fully went there? Okay, well, let's watch the video. Let's watch the video. Okay. From 0 to 0, okay. From 0 to 1, okay. Stay at 1, 1 to 0. I need to make a small break. It's just like, I cannot visualize anything in here because I'm already tired. And I already have to do it for 3 hours. Okay, so let's do a small break. Alright, so I feel like Stack Overflow debated me. Or maybe I didn't use it correctly, or something like that, but thing is, what we need to do, we need to essentially take the floor of this entire stuff, take this thing one more time and subtract this thing, because I need a fractional part. I think that might work, right? So because I just need a fractional part of this entire stuff. So let's give it a try. I'm not 100% sure because I'm already tired, right? So obviously my brain doesn't work as well as I would like it to work. But maybe we can actually go ahead and try to render it already just to see how it's going to go. Because I'm going to be looking at the values. Okay, it's staying at 1. Hopefully it's going to... I think it's working. Yeah, it's working. Nice. Cool. Okay, so let's actually train it. Yep. Alright. And let's render that. That's cool. It would be also kind of cool to show the progress of rendering, but that would be kind of difficult, right? Because that means you have to... Yeah, it could actually work to some extent, making it like sort of asynchronous. And yeah. So let me give it a try. So upscale. Let's see if it's going to, and then going back. I wonder, by the way, if you can loop. Playback. I think that's the. Can it just loop? Why is it freaking flickering? VLC, is it such an unsolved computer science problem to not flicker when you restart the video? Just like... Freaking... I swear to God. So maybe we can try a different... Just like ruining all of the vibe. Yeah, and okay, so how do you loop in VLC? What was that? MPV, right? Is it really that hard? Is it really that unsolved of a computer science problem? I don't really know. Right, loop, set, okay. Set clear A-B loop points. I have no idea what the fuck it is. Toggle infinite looping. Why do you have to toggle it? Is there any flag for that? Alright, so loop. I don't want to toggle anything. I want to just run the flag. Okay, apparently I have to toggle. MPV. Right, looping currently, yes. Finally. Look at that. Isn't that poggers? Isn't that freaking poggers? And this is what neural networks are capable of producing. And look how it kind of reuses the same hole. Right, it's just like uses the same hole in here and it's just like, yeah. That is so fucking cool. That is absolutely fucking poggers. Absolutely fucking poggers. Right, so, and maybe we can try to do the square root, right? So let's actually try the square root of this thing. Might as well, actually. Just do b equals square root like that. So it will be automatically applied for both rendering and logging. Right, so let's actually try and see. Okay, go. Okay. Okay, and let's render this thing. So right now UI is blocked, as you can see. Making it unblocked would have been really interesting. So that means you need some sort of a state machine within the event loop that effectively tells you whether you are in a training mode or in a rendering mode, right? And depending on that, you just render things differently, right? And essentially you handle the event loop along with the child process of FFmpeg, right? So, okay, I really like how square root just speed up and slow down. Look at it. Right. And when we go back, what do we actually want? So yeah, in case of the like a square root, we actually want to maybe like invert it. You can notice that. Yeah, that's why easing in and easing out so important, right? That's why it is so important. But like inverting this kind of stuff for that specific segment actually means that we need to distinguish them somehow, right? So we can maybe define a function, right? So func, which by itself is enumeration, right? So in here you can have func ID, right? So which doesn't do anything. Func sqrtf, or maybe sqrt actually. So in case of sqrt, what we want, we basically want to just invert it, I suppose, right? Though it's kind of difficult to tell. Maybe apply it to the segment progress. It's basically the same as applying it to B, because we are using segment progress to interpolate between start and end, right? And that's base. Well, I see what you mean. Yeah, I see what you mean. So maybe that's the thing. Yeah, that's a good one. Thank you, Assassin23. Right. So I was about to actually over-engineer my solution, but you saved me, I think. Okay, go. I'm sorry for beatboxing. I know that it kind of like interacts with the currently playing song, not in a really good way. And this is how inverse square root was discovered, I suppose. Elevator music when? I don't know what to tell you. Can we just like speed it up? It's really like, I really like this image, because for this neural network sometimes it is really hard to close that loop, right? So sometimes it really struggles to find the configuration that closes that loop. It just depends on like from what yeah, now it is easy for it. It just like really depends on how it starts. Oh, this one is good. Yo, look at that. This is such a cool thing. Let's actually make it a little bit more refined. I guess it's fine. Okay, let's go ahead and render this. Yo, what the fuck? Easing function actually makes it look better. It's just... So that's why these easing functions are so important. They make it look good, right? So that's the whole point. This is so fucking awesome. Now this is something I would post on Twitter. Yes, finally, some Twitter content. So yeah, that is very progress. Imagine like actually like doing something more complex with more complex images and stuff like that. But with more complex images, they have a higher resolution, which means that we have a lot of training data, right? Some of the things we'll have to implement if we want to work with bigger images is sampling, right? Essentially, we don't want to turn each pixel of the image into a training sample, right? We want to turn only specific random samples, and we want to randomly sample this entire thing. And the question is, how can we sample an image? We have to implement a blue noise, right? So, and basically the stream where we're gonna do that will turn into like a blue noise algorithm exploration. Though the simple blue noise algorithm is actually super easy to implement, right? So, yeah. As far as I know, they are using like very simple heuristics that allow you very quickly, like in linear time, generate like n samples. Can it make 25 FPS cartoon into 60 FPS? Well, I mean, if you watched the stream, you would have known the answer. All right, so that's pretty progress. I guess that's it for today. Thanks everyone who's watching me right now. I really appreciate that. So have I acknowledged the subscribers? I'm a robot. Thank you so much for 39 months. Thank you. Really appreciate that. All right, so that's the today's stream. That's the result of today's stream. Look at that. Isn't that poggers? That's absolutely freaking poggers. I'm gonna work on that a little bit more off screen and maybe come up with something cool and maybe post that on Twitter. Right? So yeah, right, that's it for the day. Thanks for everyone who's watching me right now. I really appreciate that. Have a good one, and I see you all on next recreational programming session. Love you. Mwah.